Okay, so this fraction compared to the previous one, there's a difference here now. Now, how is this different? First of all, let's look at what's similar. Right. Let's check the degree of the denominator. So what is the degree of the denominator? If you had to multiply this out, there's an x squared there, and there's an x to the power 1. So therefore, x squared times x will give you x to the power 3. So the denominator is of a third degree. Right, so now, if it's third degree, you must have A, B, and C. Right, because there's going to be 3 fractions. But now, let's look at this one here. We got 2x plus, okay, let's rewrite our fraction first without our integration. 2 over x squared plus 4 times 2x plus 1. Now, previously, as I showed you, if we had 1 over maybe, let's say x squared minus 1. This is the same as 1 over x minus 1, x plus 1, because this can be factorized. It's a difference of 2 squares. And now I have my 2 fractions. I can write it as a over x minus 1 plus b over x plus 1, because I must have 2 constants because it's second degree. Can you see that? But we have a problem here with this one. This is x squared, it's a square. This is 4, but it's not the difference of 2 squares. There's a plus sign here. Now this cannot be factorized. So if it cannot be factorized, but still because of the 2, you need both a and b. Right. So the way to write it is only for a quadratic which cannot be factorized. So we can, this is how you do it. You're going to go ax plus b all divided by my x squared plus 4, because there's not, you cannot split this up. So therefore you cover up by writing ax plus b. You cannot write a plus b. Okay, it must be ax plus b, or you can go bx plus a, doesn't make a difference. Plus, now you are done with this, you covered a and b. Now it's the 2x plus 1, so that will be c all over 2x plus 1. So remember, this is the quadratic which cannot be factorized. If your quadratic can be factorized, then you must factorize it. Okay. So now, that's the only difference in the beginning compared to the other examples that I've been showing you. The rest is the same. What am I going to do now? I'm going to multiply by this denominator on both sides. Let me do that quickly here. Right, so what is our denominator that I'm going to multiply by? Here's our denominator. So which is x squared plus 4, 2x plus 1. Whatever I do on the left hand side, I must do on the right hand side. So the rest is the same. It's just that the first part, where you had the quadratic which cannot be factorized, this is how you write it. Now you might be wondering, could you have started with the first one? Yes, you could have done this here. You could have went a all over 2x plus 1, and then the quadratic, you got your x squared plus 4, then you will write it as bx plus c. Nothing wrong with this, yeah? Okay, the main thing is you got your x multiplied by a constant and a different constant. You can see that. So you could have done it this way if you are wondering. Now, what do we do? It's all about, let's check what's cancelling. What are we left with on the left hand side? Just 2. On the right hand side, these two cancel, I end up with ax plus b times 2x plus 1. You're clear with that? Plus c, 2x plus 1 and 2x plus 1 will cancel. You end up with x squared plus 4. Now, what are we going to do? We need to substitute values. So we can substitute values for x. And I'm going to show you, let me see if I'm going to do the other technique here. Okay, let me change this here. Let me show you the method of equating coefficients, which you will find in your book also. There are two methods. One method is to just substitute values, which I've been doing previously. The other method is to equate coefficients. Alright, so let me just write this down. I'm using the method of equating coefficients. So how does equating coefficients work? I'm going to remove the brackets. So if I remove the brackets, ax times 2x is going to be 2ax squared. Ax times 1 is going to be plus ax. Then b times 2x is going to be plus 2bx. And then b times 1 here is going to be b. And then if I remove the brackets here, c times x squared will be cx squared, and c times 4 will be plus 4c. Okay, now what I'm going to do is group all my common terms. I've got x squared and x squared there. So if I take out my x squared as a common factor, only looking at these two, nothing else. When I say common factor, I don't mean from everything there. I'm just grouping my x squares. So I have 2a plus c. Okay, there's my 2a, there's my c there. Now, I'm going from highest to lowest. I'm dealing with the x squares, then I'm going to deal with the x, and then the constants. So, the terms with x, how many terms do you see with x here? This one and that one there. So, if I take out x as a common factor, what am I left with? A plus 2b. Is there any more terms with x? No. Remember, if you remove the brackets, it will all go back to how it was. And you can always check that. Now, what are the constants? Are there any constants here? Anything left? That's not a constant, that's x, we got b plus 4c. b plus 4c. Alright, so now, on the left hand side, do I have an x squared? No. I'll call it 0x squared. On the left hand side, do I have an x? No. So that's going to be 0x, and I only have 2. Now, what am I going to do? I'm going to equate the coefficients now. So let's start with these two here. Alright, so what will I do? I'm going to say that 0x squared on the left hand side, and on the right hand side I got 2a plus c times x squared. So the coefficient of x squared on the left hand side is 0, must equal to the coefficient of x squared on the right hand side, which is 2a plus c. Now, let's deal with the next one. I have 0x on the left hand side, and on the right hand side I have a plus 2b times x. So, the coefficient of x on the left hand side is 0, and the coefficient of x on the right hand side is a plus 2b. Okay, now finally the constant on the left hand side is 2, must equal to the constants on the right. Constant is anything that does not have x multiplied by it. Must equal to the constant on the right, which is b plus 4c. So that is the method of equating coefficients. Certain examples you might want to use both methods. Now, let's see, do we need to use both methods? When I say both methods, I mean substitution also. To work these A, B, and C faster. Now, these are all simultaneous equations. Now I've got equation 1, equation 2, equation 3. So, what can I do? Let's see. I don't want to make things difficult and take too long to work it out, especially in the exam. So, I have these 1, 2, 3 equations here. Right. Let me go do a substitution to find one of them. So, let me go here and there. What value can I substitute for me to get an answer quickly? Minus half. Minus half, exactly. Can you see, everyone see that minus half is a value that's going to get to our answer faster than any other thing? Right, because straight away, why is he saying minus half? Because this is going to become 0. And 0 times anything here is going to be 0. So therefore, I only have C to work out. So let's do that. So if I say let x equal to minus half. On the left hand side, I have 2. On the right hand side, you know that's going to be A times minus half plus B. Although it's unnecessary to write this down, you know it's going to be a 0. 2 times minus half plus 1 there. Then we got plus C, and then we got minus 1 over 2 squared plus 4. So now we got 2 is equal to, you know that this is going to be a minus 1 plus 1 is 0. 0 times anything here, 0. Then here, what do we get here? 1 over 4 plus 4 here. So that's going to be 17 over 4 C. You can work that out on the calculator. So now C is going to equal to 8 over 17 if you divide by 17 over 4. Alright. Now, I have C. Now, can you see how easy it's going to be now? Since I have C, look at this equation here. If I substitute for C here, I can work out B. Even this equation here, if I substitute for C, I can work out A now. I have both in front of me now. So this is using both substitution and equating coefficients. You will see it will be useful for the very long examples. This one is not a long example. It's actually an easy one. Right. So let's go to this one here. 2 is equal to B plus 4C. Or if you want to, you can still use a substitution again. You can maybe put x equal to 0. If I put x is equal to 0, 0 there, 0 there, 0 there, it will work. You can try that out. But let me use this one here for now. So 2 is equal to B plus 4C. So 2 is equal to B plus 4 times 8 over 17. So 2 is equal to B plus 8 times 4 is 32 over 17. So then we got 2 minus 32 over 17 is equal to B. So that's going to be 34 minus 32, which is 2 over 17, is equal to B. So I got C, I got B, only A left now. So let's go to this equation, this one here. 0 is equal to 2A plus C. So 0 is equal to 2A plus C, since we already know C. So if I go 0 is equal to 2A, what was my C? 8 over 17. So if I take 2A to the left, minus 2A is equal to 8 over 17. So A is going to equal to minus 4 over 17. You can divide by 2. So what happens now? We take all this information and put it back here. Right, so now, therefore, the integral of 2 all over x squared plus 4 2x plus 1 dx is equal to so my a was minus 4 over 17 plus 2 over 17. There's my ax plus b, and my c was 8 over 17. So we found our a, b, and c. Now we need to integrate everything. So how do we integrate here? We now need to separate these two into different fractions. So now the integration, we're going back to our M5 work, the last part. So if I let u equal to x squared plus 4, the derivative is 2x. Then it will not cancel because of this term here. Can you see that? So the u substitution, it does not cancel perfectly. So what we're going to do is split it up into two fractions. So I got my integral there. I got minus 4 over 17x all over x squared plus 4, and then I will have plus 2 over 17 all over x squared plus 4 dx. So that's what I mean by split up into two. Here's my common denominator, x squared plus 4. All I did was separate it into two fractions. Plus, this is 8 over 17 divided by 2x plus 1. Now I'm going to do the last part, which is the integration. Okay. So what I'm going to do now is I'm going to use the method of inspection here because of time we're rushing. Let's assume you're rushing in the exam too. Okay. So before I do that, I need to get everything in correct order. So I'm going to take any constant and I'm going to write it in front. So that's minus 4 over 17. That's x all over x squared plus 4 here, plus 2 over 17, and then I got 1 over x squared plus 4 there. But now you must recognize the lesson that we did yesterday, that this term here, you have an x squared plus 4 in the bottom here, but there's no x to cancel on the top. So therefore you complete the square. So you're going to write it as 2 squared plus 1 squared times x squared. Basically, it's already in order for you. All you have to do is write them as squares. This one here, you got plus 8 over 17 times 1 over 2x plus 1. Now, I'm going to show you the inspection method. Okay, so this one here is a fraction where the numerator is an exact derivative, is a derivative of the denominator. These two here are the same type of integration, same type. This one is different. Right, so now, what do I mean? I'm talking about this type here. K f prime x all divided by f of x dx, and the answer is always k ln of the denominator plus c. So that's what I'm talking about. So now let's check. You can write down ln of the denominator only if the numerator is an exact derivative of the denominator. Now watch this here. This is inspection. So is the numerator an exact derivative of the denominator? It's not exact, it's almost. So the derivative of x squared is not x. What was it supposed to be? 2x. So if I go and write down a 2 on the top, I need to divide by 2 because there was no 2 there originally. I am writing down a 2. So if I write down a 2, in order to cancel the 2, divide by 2. Can you see that? That is inspection. Now divided by 2 is the same as 1 over 2. Same story here too. What is the derivative of 2x plus 1? It's supposed to be a 2. So if I put a 2 there, I must divide by 2 to cancel it. So there's my 1 over 2. Now, there's this whole part here, minus 4 over 17 times 1 over 2. You work that out. What do you get? You get minus 2 over 17. You're clear with that? And now, f prime x on the top, f of x in the bottom, so the answer is ln absolute value of x squared plus 4. Let's do this one here. This 8 over 17 times 1 over 2 is the same as 4 over 17. The numerator is an exact derivative of the denominator, so we take ln absolute value of 2x plus 1 plus c. Now let's look at the middle one. The middle one, you go to your formula sheets and you need to choose the correct formula. That's integration by completing the square. You are looking for this one here, a squared plus b squared x squared, which is equal to 1 over ab inverse tan dx over a plus c. So here, I got my plus 2 over 17. And then, which was part of your constant there. The formula is 1 over AB, so that's 1 over 2 times 1 inverse tan bx, so that's going to be 1x over 2. What happens here? 2 and 2 will cancel that, and then you can do that. I don't have space here, but basically that is the integration by inspection. Okay. We continue tomorrow with more examples.